In this problem, we're given some information about the number of milligrams of sodium per serving, and we're supposed to make a histogram. Now, the thing that seems to be throwing few students off is that you'll notice it gave us the count of the number of different cereals that had each amount of sodium, but it didn't give us the percentage. So we know how to go and find the high if we have a percentage, but we're not remembering how to find the actual percentage. So when we look at this, we'll say, okay, first of all, how many types of cereal did they look at? So we want to add up 4 plus 3 is 7, plus 7 is 14, 16. It looks like there are 18 different cereals. So anytime you want to find a percentage of something, we just divide how many we have by the. So if I want to find the percentage for this first category, there are 4 types of the cereal out of a total of 18. And then you always, so you divide by the total and then you times by 100%, which in this case, 4 divided by 18 times 100% gives me 22.22%. So that would be the percentage for this first category. The next category, we do 3 divided by 18 times by 100% gives me 16.66%. So that's how you go through and find the percentages, is how many you have divided by the total times 100%. Okay, now that we have that, that was the percentage. How do we find the width and the height? So let me make my columns a little bit bigger here. So that was my percentage. Let's find our width. So the width, you just always subtract to figure out what the width is. So you go from 100 to 150. So 150 minus 100 gives me a width of 50. My next category goes from 180 to 150, or 150 to 180. So we subtract that and we have a width of 30. So that's how you do width. Now let's do height. Okay. Now on our formula sheet, one of the few formulas we have, it says percentage equals width times height. Okay, so to find an area of a rectangle, it's always width times height. And our percentage lines up with our area. So our percentage equals our width times our height. So if you want to find the height instead, we'll just rearrange. So I'll divide both sides by width. So I'll divide by width, divide by width. Sorry, the department will only let me put one of these formulas. I can't put them both, so you have to memorize it or just try and rearrange it there. So we can rearrange. This becomes our height equals the percentage divided by the width. So in our case, we have a percentage of 22.22% divided by a width of 50, which gives me 0.44 if I round to 2 decimal places. For my next one, I have a height of 16.66%, and I'll divide by a width of 30. Gives me 0.55. So you can do the rest yourself, but for the other categories here. But we found our percentage, we found our width, we found our height. Now let's construct a histogram. Make sure to label the axes properly. So along the horizontal axis, we always put what we're looking at. So in this case, we're looking at sodium in milligrams. So the variable name, what we're interested in, is the amount of sodium. But you always need to put your unit, so you can say in or just put in parentheses, we're dealing with milligrams. Just so you know what you're working with, because sodium in milligrams would be very different than sodium in, say, ounces. And your vertical axis is always the percent per whatever your unit is. So our unit is for the horizontal axis, which was milligrams. So percent per milligrams. We got a new pen and it does not work very well. Now, as far as graphing it, I could put a scale. Now, you might pick a different scale than me. that's just fine. It's not going to hurt anything as long as you're accurate on your scale. So I'll go by 50, 0, 50, 100, 150, 200, 250, 300, 350. And it looks like we have pretty small numbers for our heights. So I'll go by 0.1s. So 0.1, 0.2, 0.3, 0.4, etc. 0.5, 0.6. Now let's graph it. So for the category of 100 to 150, it looks like we need a height of 0.44. So 100 to 150, we want a height of 0.44, so about there. Fill it in. From 150 to 180, we need a height of 0.55. So 180 is about there. And so that's the first two bars of my graph. Now you might notice on the key, they picked a very different scale than I happen to pick right now. That's just fine. It just changes the look a little bit. It's okay. Oh, it does look like you probably need a different scale because you do need to go all the way up to 1.95. So change your scale a little bit, but this is the basic idea of how to make a histogram.